Hello, my name is Mike Siepel, and I'm one of the engineers at MontageStudio. We've built a platform for authoring web applications with inspiration from the native world, while fully embracing the nature and opportunities of web development. While we typically target applications, not games, we happen to have some great engineers that are very active in the 3D world, and clients with reciprocating demands. So while we're not necessarily a solution for building large, demanding games, we do offer a great way to easily integrate WebGL content into complex applications. Today I'd like to give a quick overview of our approach to this integration by building a few apps, such as these seen here. Of course, the heart of MontageStudio is our open source framework, MontageJS. Our framework espouses all the principles that we desire when building applications, and we're sure you'll come to appreciate the same. For starters, MontageJS exhibits clean separation of concerns at every level to partition work and streamline collaboration. A single view in MontageJS is represented by a component. That's a great example of where you can see this separation of concerns at play. The component itself represents semantics, style, and behavior of a view. Each of these concerns is already well represented in the web stack by using HTML, CSS, and JavaScript respectively, so we just use them. Here's all the code to the application I'll build for you in a moment. We'll start with the spaceship. You can see our HTML template. It's pure HTML. We have no templating language. There are no handlebars, mustaches, or custom tag libraries. Generally, there's not much for a designer to be wary of, or much for them to learn. This really is a boon to teamwork. The CSS is linked as you'd expect, although there's nothing special to see there in this demo. Likewise, the JavaScript is regular old ES5. This is where you'd add actual value to your application by reacting to user events, massaging data, sending it along to where it needs to go. But our demo is focused on 3D content today, and there's no reason to write custom code to populate and present a scene. Of course, you must be wondering where the scene is. There's no mention of a spaceship yet or a 3D view, other than the placeholder you saw in the HTML template. So that's where we rely on our declaration. Our declaration is what associates other components with the elements found in this component's template. This could be as simple as specifying a button should go here or a slider should go there, but in this case it's a 3D scene view that we want in our component. The association from component to element is discovered via the data montage ID attribute you saw in the HTML template. But not all objects in the declaration need to be components found in the template. They could also be plain old JavaScript objects or controllers. Or in our case, they could be objects from a tree of another sort. Perhaps the node hierarchy from a WebGL scene. We can pick and choose the members of a scene graph that we want to expose in the declaration, just as we did in the HTML template. It could be the scene itself, a node inside the scene, or even a material. Regardless of where the object come from, they are all now required, created, and made available to the component we're building. This abstraction is one way we help layer the lines between HTML and WebGL and really any other structure we can pull objects from. MontageJS embraces declarative programming to reduce the tedium of the mundane. This approach has served us well already for years in HTML and CSS, and we appreciate the flexibility and speed it brings to building MontageJS apps. You can see our declaration format here. It's plain old JSON. In addition to offering to take over the mundane task of creating objects, MontageJS further offers declarative facilities for configuring their properties, listening to their events, and transporting data between them. It's all here. The declaration JSON file itself is usually included in the HTML template as a script element, but it could be in its own file if you want. And each one of these concerns finds its home encapsulated inside the component on disk in a directory. So all the requisite parts of a component are found in the same place. You don't need to hunt and peck throughout your application to find the CSS file or the HTML. And while that declaration is straightforward, it doesn't look like it saves a ton of typing. Thankfully, this declarative approach lends itself exceptionally well to tooling. And while I could go on about other awesome features we have, such as our reactive two-way bindings, our jank-free draw loop, or our participation in the Node and NPM ecosystem, I'd rather show you where this all leads in MontageStudio. MontageStudio is a web application written using MontageJS, and here it is. Here I've opened up a project that we're going to work with and put a 3D scene in place. On the left we have the files that make up the project. Further along here we have a representation of the declaration. For every object in the declaration, we'll have a corresponding representation here. We have a preview of the stage that we'll be working with, and then down below we have the HTML template. We also have on the right a library that's populated by all the dependencies that we have, so each one of these is an NPM package that provides some componentry for us to use. I'm going to work with this one in particular to bring in a scene, simply drag it and add it to our template, and a scene view that's a component that will present that scene. With these added into our template, now it's simply a matter of configuring them. Go to our asset library, find the spacefighter model, and associate that with the scene. Then we'll choose our scene view and grab a reference from the scene and tell the scene view to present that scene. And there you can see that we're up and running. I've also connected a couple previews here, and you can see that those updated live. In fact, any of the options that I put in place here will impact the scene immediately. These previews could be different browsers, different devices, local, or perhaps even far away, over the internet. See, each one of them is live and we'll be updating as we edit. In addition to setting properties, we can also explore some of the objects we have in more depth. For instance, the scene, we can explore with a custom inspector. Here we are, viewing the model outside the context of the application. We can use hit testing to actually select the node of the spaceship, and then browse through its materials to find the body material. Drag that, and we can add that to the template as well. From here, we can actually now customize some of the properties. By choosing a different texture, you can see that all the previews have updated live, and we're now presenting the ship in its alternative camo. For our next demonstration, we'll enlist the help of a friendly penguin. Here's a tux model being presented by our scene view. We'll come in here, but of note, I'd like to peek inside the CSS for this component. There's an animate class name available that when in effect, or with the hover in effect at least, will scale along the z-axis 1.5 times. Let's go back into the reel here and select the hat node. It has been exposed from the scene graph. We'll put a binding in place. Here the animate class name will be present whenever the source path is true. We'll make it always true. With that binding in place, we can switch back. And now you can see that as I hover over the hat, it scales as expected. We've reached into the scene graph using CSS and declaratively told it how to behave. It doesn't do anything when I click on it though. I'd like it to. Here we can grab an event from the hat and listen to it from our owner component. When we handle the action event that that node emits from inside the WebGL scene, we'll react to it. Go over, hover still works, and now when I click, you can see that we get a new message. And there you can see that we've really blurred the lines between WebGL content and HTML, and that's just something that's afforded by the normalization that we have of all our objects in the declaration. As a further example of our tight integration with WebGL content, I present the Eco Home demo. Here we have a model on the left that's presenting a pleasing flyby of a house that you can configure ahead of purchasing it. We can also grab control of the camera, of course. And otherwise we can cycle through some of the options that are available for installation. Some of the options will actually trigger presenting a particular viewpoint to hone in on exactly what's being configured. We can of course populate, change the nodes and the materials. And we can use any manner of different controls to actually accomplish this. Some of the controls, of course, are quite rich. Here, for example, is a thermostat that we can use to control. But it'd be nice if this had some impact on the scene, just like all our other controls. So we can hop over here to our WebGL view, find the particular material that we want that's in the scene. In this case, the HVAC material is presented on top of the floor, and put a binding in place. The material will actually present a particular filter color when the owner, well, it'll present the floor color of the owner. Put that in place, and now coming back over here and installing the thermostat, looking down at the floor of course, cranking it up, and you can see our in-floor radiant is piping hot, or icy cold. And while I said we don't do games, there's nothing that stops us from making a casual game, of course. Here's a beach planet model with some montage logos hidden throughout. All the user interface presented is of course just HTML. We can control the camera and then hunt for the logos. So you can see us reacting to events, performing the appropriate action as expected. We also have the culmination of some of the CSS work we've done, so you can of course inflate the raft. And really, that's about it. This is the hardest one for me to click on. And so there you have it. It's how MontageJS and MontageStudio make it easy to integrate WebGL content into your complex web applications. Be sure to check us out at montagestudio.com and sign up for early access to our MontageStudio product. Thanks.